Hey world, I'm Rita, and today we are going to explore together something really fun, that is the decimal number system. Decimal number system is a number system that we use almost every day in our daily lives while counting money, while reading temperatures, and so many more. Basically, this is a style of writing numbers, and trust me, this is not very mathematical. This is really fun and interesting. Let's understand it together. So what is decimal number system? As I told you, it is the most common way of writing numbers. And sometimes it is also called base 10 number system or denary numeral system. Commonly we call it decimal number system, but anywhere if you see these terms like base 10 number systems or denary numeral systems, then you will understand that we are talking about decimal number systems. So a decimal number system is divided into three parts. It has a whole number, a fractional part, and these two parts are separated by a decimal point. What does it mean? Let us understand by an example. So this is the way of writing decimal number system. So here you can see this is a whole number, 275. After that we have 35 again after a point. This 35 is called the fractional part. And in between we can see a dot. This dot is known as the decimal point. Now how to read this number? This number is read as, or it's pronounced as 275 as it is. Then we use the term point, 275 point. Now 35 is not read as 35. It is read as 35. So this number will be called as 275.35. Okay. So basically why we use these numbers? These are just like fractions. Decimals are just another way of representing a part of a number. What's that? Let's take an example. Consider a number line. So this is our number line. It starts from 0. After that we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now let's forget all the other numbers and let's focus on 0 and 1. Stretch this part of the line, and the length between 0 to 1, let's divide this into again 10 parts. The first part after 0 will be called as 0.1. So this is the first decimal part. Next one will be called as 0.2, then 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, and then we have 1. That is the next number of the number line. But 1 can be also written as 1.0. They are the same things. 1 and 1.0 are the same things. If we stretch the line further, then after 1.0, or rather we can say after 1, we will have 1.1, 1.2 and so on. 1.0, 1.1, 1.2, let's stretch it more, 1.3, 1.4, 1.5, 1.6, 1.7, 1.8, 1.9. What will you, can you say what will come after this? Okay, so 2 comes after 1.9 and 2 can be also written as 2.0. After that, 2.1, 2.2 and so on. So basically whenever you divide any consecutive number into 10 parts, consecutive means suppose 0 and 1, they are the number next to each other, so they are consecutive numbers. If you divide these two into 10 parts, and if you have to write it in fraction, how would you write? Remember the fraction playlist? If 0 to 1 are two numbers and we divide this length into 10 parts, then the total number of parts will be as the denominator. So in the bottom we should write 10 if we are writing in fraction. And what will be the numerator? Remembered Frankie? Let's say Frankie wants to sit at position 4. So 0, 1, 2, 3, 4. We will put frac here and our numerator will be 4 upon 10. But if we have to write the same number in decimal, what would you do? Just look in decimal, if this is 0.0, then the next numbers are 0.1, 0.2, 0.3, 0.4. Where is Freki sitting? Freki was sitting at 4 upon 10 and that part is exactly the part that coincides with 0.4. So 4 upon 10 can be also written as 0.4. These are the same numbers. So from here we got to know that 4 upon 10 is known as 0.4. Similarly, if we have 6 upon 10, look where is 6 and which decimal number coincides with that point? Yes, 0.6. Correct answer. If we have to write 4 upon 10, it's 0.4 in decimal. If we have to write 6 upon 10 in decimals, it will be 0.6. Tell me, what will be 9 upon 10? It will be 0.9. Correct. So since from the beginning we have been continuously dividing the length between 0 to 1, do you think decimal means only fraction with a denominator of 10? No. Decimal can also represent fractions with denominators that are multiples of 10, like 100, 1000 and so on. Okay, let's divide the line 0.1 to 1.0 in equal parts again. So we have from 0.1 to 1.0, this division can continue further. As we know, 1.0 is the same as 1 and the number line can go beyond 1 up to, 100. Let's take an example. Let's take an example of a rectangular box to understand this better. Now divide this box into 100 equal blocks. Now let us do one thing. Shade 39 blocks with blue color. So since the total number of blocks is 100, the denominator will be 100. But we have shaded or used only 39 blocks. So the numerator will be 39 if we have to write it in fraction. Now, can you tell me how to write this fraction 39 over 100 as a decimal? Okay, let's do one thing. We will start counting from 0. Now 0 is not the first block. The first block should be counted as 1. So let us keep 0 outside the block. Now should I write 1 in the first block? No. The entire box is one box. The whole box is 1. So I will write 1 at last. I have divided the whole one box into 100 small blocks. So let's call the whole box as box and let's call one part, each small part as blocks. So the first block should be not 1, it's 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9. What should come after 0.9? 1.0, which is also equal to 1, we have learned. But wait, if here is 1, then at the end of the entire box, the last block is also 1. So, where should we put 1? It's not matching. This is wrong. 1 should be at the last. Then, what to do? Let's leave all this. Let's do it one more time. Now, instead of 0.1, let us call this 0.01. The first block we will call like this, 0.01. Let's see what happens. After 0.01, do you know what should be the next block called as? 0.02, 0.03, 0.04, 0.05, 0.06, 0.07, 0.08, 0.09. What to do after that? 0.09, after that we will do 0.10. So basically after 8, 9 we are giving 10. But we will not call it 10 because after the decimal point we have learned that we have to call it like 10. Now what does this 0.10 mean? We can strike off any zeros which are at the end, at the rightmost side of decimal point. We can strike them off. Just like we can strike off 1.0, we can strike the 0 from there and we can call it 1. Similarly, from 0.10, we can strike this 0 off and we can call it only 0.1. That is allowed. They are same. So 0.10 can be also called as 0.1. So our 10th block is not 0. It's not 1.0, it's basically 0.1. Okay, let's put it here. What should be after this? Remember, this is 0.1. So again, if we go back, this is actually 0.10, or in our mind we can just assume this is 10. So the next block that will be that is below 10, it should be 20. Then the next one should be 30, 0.30, 0.40 is 40. The 50th block should be 0.50. The 60th block should be 0.60. After this 0.70, 0.80, 0.90, and then the last block should be 1. But after 90, what should I have? The next, it should be 100. And we will put the point here. I told you that we'll put the point here, and I told you that we can strike off any 0 that is on the right side of the point. So we can strike off these 2 zeros, which means that we can also write it as 1. Oh, then it's matching. Yeah. All right. So similarly, 0.9, there is 0.20. We can strike this 0.200 and we can write it as 0.2. Here also we can strike this 0 from 0.30 and you can write it as 0.3. Go to the next one, strike it, write it as 0.4. Go to the next one, strike 0 from 50, write it as 0.5. Go to the next one, this is 0.6. This is 0.7. This is 0.8. This is 0.9 and this is 1. Look, this column is matching 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, and then we had 1 which can be also known as 1.0. Anyway, leave all these things. We have to count the shaded blocks. So what will come after 0.1? What should be the next block that is here? What should be this block? This should be 11. After 10 we have 11, but we will not call it as 0.11. We will call it as, yes, 0.11. Next will be 0.12, 0.13, 0.14, 0.15, 0.16, 0.17, 0.18, 0.19, and after 19, remember we had 0.20, that is 20 here, and we could have striked the 0 and keep it as 0.2. Okay, after 20 we have 21, so 0.21, 0.22, 0.23, 0.24, 0.25, 0.26, 0.27, 0.28, 0.29, and then we should have 30, that is 0.30. Next, this is our 31st block, so it will be 0.31, 0.32, 0.33, 0.34, 0.35. I hope you can pretty much guess what should be 39 over 100. 0.36, 0.37, 0.38 and 0.39. Yes. So 39 over 100 can be also written as 0.39 in decimal number system. That's our answer. Alright, so 39 over 100 can be written as 0.39. Similarly, 57 over 100 can be written as 0.57. Very good. 99 over 100 can be written as 0.99. Yes. 46 over 100 can be written as what? You tell me the answer. So now we have known that 6 over 10 is written as 0.6 in decimal. If we have 57 upon 100 as fraction, it is written as 0.57 in decimal. If we have 199 by 1000, how would you write? Now look at a pattern. This is a shortcut. You don't need to make blocks and number lines for understanding how to write in decimal. See, in 6 over 10, you have 1 0 in the denominator. For 10, we have 1 0. So in the decimal, we will have one digit after the decimal point. Similarly, for 57 upon 100, we have two zeros in the decimal. So, while converting it into decimal, we will have all the two digits 57 after the decimal point. Can you apply the similar pattern here? Here we have three zeros, 1, 2, 3. We have three zeros in the denominator. So, after decimal, we will have all these three numbers after the decimal point. So, we can write it as, what would we write it? 0.199. That's the answer. So look at a pattern. All these are proper fractions. 6 upon 10, 57 upon 100, 199 upon 100. Whenever you have a proper fraction with denominators like 10 or multiples of 10 like 100, 1000, 10,000, whatever, you will just use this pattern on this shortcut to convert the fractions into decimal. Now, what if you have a fraction like 7 upon 4? Can you convert it into decimal? The denominator is not 10, neither it is a multiple of 10, it's 4. Can you convert it into decimal? Yes, any number can be converted into decimal, any fractional number. Okay, but that we are going to learn in the next video. So we can have fractions like 7 upon 4, 13 upon 10, 125 upon 1000. I think you might be able to do this and this, 13 upon 10 and 125 upon 1000. Try, use your common sense. But these are the things that we are going to learn in next video, that how we can change mixed fractions or any kind of fractions, improper fractions, into decimal. Okay world, thank you for listening to me. See you on the next video and let's explore decimal more on the next video. Bye bye for today.